Okay, today we're going to talk about chords and angles. We're going to start with what is a central angle. Now, for those of you guys that don't remember, central angle is an angle that's in the middle of the circle. So AOB is in the middle of the circle. The vertex is in the middle, the edges are on the ends of the circle, or the edges of the circle. Same thing with DOA and DOB. Now, if you look on the right, these are ones that are not central angles. Notice that there are no angles where both parts of the angle are in the center of the circle. So if they're outside the circle, it doesn't count either. Everything's on the inside of the circle. That's going to be important with one of the examples we do later. We're going to talk about chords and their central angles. So the first thing we want to look at is when we have congruent chords. So remember, a chord is a line segment that goes through the circle, pretty much touches edge to edge without going through the center. Now, if I know that the two chords in a circle are the same, that means the central angles that are connected are also the same. They're congruent. So that means in this case, AOB and COD are exactly the same. That will help me when figuring out angles and missing pieces. If I know that those are the same, I know that the angles are the same, and they're vertical angles almost. But that way, at least I know for sure that they're the same. Next thing we have is when we have congruent chords and congruent angles. What does that mean for the arcs on the outside? Well, in this case, that means that those arcs that are on the outside are congruent. So if you see the ones that are with the question marks on, those are the arcs in question. Notice the angles, they touch those arcs. That means those arcs have the same measure. So if I know the angle on the inside, I also know the angle on the outside. And that means that they're going to be the same. So I don't have to try to do any more arithmetic to figure that out. I'll just know exactly that they're the same. Next thing I want to look at is when we have perpendicular segments. So in this case, the perpendicular from the center of the circle to the chord is what we call the bisector of the chord. Now, if you remember what it means to bisect something, that means to cut it in half. So if I have a segment, pretty much like a radius that goes from the center of the circle to the edge, and it cuts a chord to where it's a 90-degree angle, it also cuts it in half. So that's going to be really important. We also know that two congruent chords in a circle are equidistant from the center of the circle, very close to the same thing. So if you look at the top, those two pieces, or set of four pieces, would be the same. Then you have this. If I know that the chords are the same, that means the distance from the center to the chord is also the same. So a lot of pieces that tend to be the same within it, as long as you pay attention to the markings, you should be able to figure that out just fine. In this case, the perpendicular bisector of a chord. So if I know that I have a right angle and it cuts it in half, it also means that it has to go through the center of the circle. That means that black line from the center to the edge has to be a radius. Okay, so if it's not going through the center, it won't cut it in half and it won't be at a 90-degree angle. So it's got to have both those things in order for it to work. Again, the diagrams are going to be the most important thing that will help you out with this. If you follow diagrams, you should be able to get the answers right. Now, in this example that we have, looks like I've got a triangle. I've got ACB is a big triangle, split up with C and D. I know that there's a right angle on the inside. I'm also told that AB is 14 centimeters. I'm told that arc AB is 110 degrees. We want to find two things, angle CAD and angle DB. Well, if the arc is 110, and I'll put that here on the screen, what does that mean for the central angle? That means the central angle is the same. Now it looks like line CD cuts it in half. In fact, because I got that right angle there, it does cut it in half. That means each of these angles is 55 degrees. Now if you remember, a triangle adds up to 180. So if I've got 55 and 90, that means angle CAD must be 35 degrees. DB is the next thing we want to find out. I know that the whole thing AB is 14 centimeters. Since I have that right angle there, and it's coming from the center of the circle, that means each of these is 7. So AD is 7, which makes DB 7. So keep in mind that anytime it goes from the center to the chord and makes a 90-degree angle, those two pieces are going to be the same. Hopefully that'll be pretty easy to find out. Here's another diagram here, going from the center of the circle to the chords. I know that the chords are the same because it says AB equals CD. So since I know that the chords are the same, I know it's a 90-degree angle, that means that those two pieces have to be the same. So that means 2x plus 6 has to be equal to 24. If that's the case, I can set up an equation. 2x plus 6 equals 24. Subtract 6 on both sides. I get 2x equals 18. Divide by 2, I get x equals 9. So these are two examples of problems that you will have. A lot of times it's a matter of matching things up. Once you do that, it's either a simple equation like this, or you should be able to pretty much figure it out easily. Make sure you follow the homework instructions in terms of which homework assignment you have, but also you might have seen something in these last two slides. It might be advantageous for you to pay attention to that, but we'll see who finds out about it.